So, second video on partial fractions. Consider the two algebraic fractions given, 2 over x plus 1 plus 3 over x minus 2. In third year, you were taught how to combine these two. So, we have a common denominator that is a combination, a product of both the existing denominators. And so if we multiply this denominator by x minus 2 to get the common denominator, we must multiply this by x minus 2. We multiply this denominator by x plus 1 to get the common denominator, so we must multiply the 3 by x plus 1. That gives us 2x minus 4 when we expand the brackets, plus 3x plus 3 over, I'm not going to expand these brackets, 5x then, minus 4 plus 3 is minus 1 over x plus 1, x minus 2. So you can do that, you've done it before. What we want to do now is to go in this direction here. Now we're not going to use these steps, but we are going to start off with something like this and end up with something like this. So here's our first example. What we want to do is to express this as partial fractions. Now if we look at the terms on the bottom line, this is a linear factor because the power of x is 1. This is also a linear factor because the power of x is 1. Now these two are different. That's why we talk about distinct linear factors in the denominator. So what I want to do is I'm going to have something over x plus 1 plus something over x minus 2 added together to give me 5x minus 1 over x plus 1x minus 2. So that's how you'll start. Now, the next line I'll put in on the first couple of examples, but then leave out. So what we want to do is to join these two into 1. So that's our common denominator. I multiply x plus 1 by x minus 2 to get the common denominator. I must multiply the a by x minus 2. I multiply this x minus 2 by x plus 1 to get the common denominator, so I must multiply the b by x plus 1. Okay, now this here and this here are the same. So what we're going to do is to compare the numerators. And on the left hand side of the equal sign I have 5x minus 1, and on the right hand side I have a lots of x minus 2 plus b lots of x plus 1. So how do we work out the values of a and b? We choose values of x which will find us a and b. Now this is a nice simple question. I'm going to choose x equals 2 because when I put x equals 2 into this bracket it will disappear. So I have 5 lots of 2. 5 times 2 is 10 minus 1 is 9. I have 9 on the left hand side. This whole bracket here, this bracket here becomes 0 because x is 2. 2 take away 2 is 0. 0 times a is 0. when I put the x equals 2 in here, 2 plus 1 is 3, so I have 3b. And if 3b equals 9, that means that b has the value 3. What other value of x can I choose? Well, if I choose in this position x equals minus 1, it'll have a similar effect. So 5 times minus 1, I'm evaluating the left hand side, 5 times minus 1 is minus 5, minus 1 is minus 6. Now if I put minus 1 in here, what do I get? I get minus 3, minus 3a, and a then has the value 2. What I can then do is state that 5x minus 1 over x plus 1 times x minus 2 is 2 over x plus 1 plus 3 over x minus 2. And if you look back to the very first slide, that's what we started with. Example 2. Now I'm not going to do all of the working for example 2. The problem is slightly different anyway. What we have is 4x plus 5 over x squared plus 3x plus 2. Now the first thing to notice is that we have a quadratic on the bottom line. We must factorise the quadratic. So nice and easy. And the next line then is just to have that equaling something over x plus 1 plus something else over x plus 2. Now, this is the line that I wouldn't normally put in. If we combine both of these terms over a common denominator, we're going to get a lots of x plus 2 plus b lots of x plus 1. Comparing the numerators, we have 4x plus 5 equals a lots of x plus 2 plus b lots of x plus 1. So we're going to choose values of x which make these brackets disappear. I'm going to choose x equals minus 2, that'll make the first bracket disappear. 4 times minus 2 is minus 8, minus 8 plus 5 is minus 3. Minus 2 plus 1 is minus 1, so that gives me a minus 1b, which means that b has the value 3. If I next choose x equals minus 1, minus 4 plus 5 is 1, that's what the left hand side gives us, and minus 1 plus 2 is 1, so I have 1a. I hope that makes sense. The first bracket gives me 1a. So we know that a has the value 1, it's going to be 1 over x plus 1 plus 3 over x plus 2. Example 3, final example. Now we have a problem here because we've got the power of 2 on the bottom as the maximum power and power of 3 on the top. We cannot have. So what we have here is an improper rational function. We need to carry out the division and simplification. So x squared minus x minus 2 dividing into x cubed. I could put in the 0 x squared minus 3x and I'll leave a space at the end for the constant term. So the question then is, what do I multiply this x squared by? To get x cubed, I multiply by x. X times x squared is x cubed. X times minus x is minus x squared. X times minus 2 is minus 2x. Subtract, so bottom line from the top line, x cubed take away x cubed is 0. 0x squared take away minus 1x squared is 1x squared, and minus 3 minus minus 2 is minus 1x. So the question we ask now is, what do I multiply this x squared by? To get this x squared, I multiply by 1. So 1 times x squared is x squared. 1 times minus x is minus x. 1 times minus 2 is minus 2. Subtract, bottom line from the top line, x squared take away x squared is 0. Minus x minus minus x is 0, and 0, I could put a 0 in here. 0 minus minus 2 is 2. What that means is that we can express this function as x plus 1 plus 2 over x squared minus x minus 2. Now, all we've done here is simplify the function. What we have to do is to express this part here in partial fractions. So this is the part that we want to work with. We have to first of all factorise the bottom line. It gives us x and x, 2 and 1, and that'll be minus and plus. And then a over x plus 1 plus b over x minus 2. Now, I'm just going to write down the numerators. So the numerator that we have on the left hand side is 2. And what will we have on the right hand side? I'll have a lots of x minus 2 plus b lots of x plus 1. Let me choose x equals 2. The left hand side is unaffected because it's a constant, so we have a 2 here. This bracket and this whole term becomes 0 when x is 2. When x is 2, we have 3b. Now, we haven't seen that before, but it is possible to get a fraction. I'm now going to choose x equals minus 1. That will make the second term on the right hand side disappear. This whole term here will disappear when x has the value minus 1. If I replace this with minus 1, I have 2 equals minus 3a. So a then is minus 2/3. And that means that we have the function written as minus 2/3 over x plus 1 plus 2/3 over x minus 2. So this is what we started with. This was our answer at the halfway stage, and we need to include this x plus 1, that's part of the function, and then it was minus 2/3, so we could write it as plus minus 2/3 over x plus 1 plus 2/3 over x minus 2, and we could maybe tidy this up just a little bit. I might write it like this. I'm going to move the last term into third place, and the negative term can go in this position here.